begin the next topic, defects of vision and their corrections. Some people cannot see things clearly due to loss of accommodation power of the lenses in their eyes. Because of defective refraction by the lenses, their vision becomes faint and fuzzy. In general, there are three types of refraction defects. Let's begin one by one. First, myopia. Myopia is also called nearsightedness. In this case, the eye can see nearby objects clearly, but the distant objects appear indistinct. This means that the far point of the eye is not at infinity, but shifts closer to the eye. In nearsightedness, the image of a distinct object forms in front of retina. There are two reasons for this defect. Number one, the curvature of the cornea and the eye lens increases. The muscles near the lens cannot relax so that the converging power of the lens remains large. The eyeball, second reason, the eyeball elongates so that the distance between the lens and the retina increases. So these are the two reasons. This defect can be corrected by using spectacles with concave lens of proper focal length. This lens diverges the incident rays, and these diverged rays can be converged by the lens in the eye to form the image on the retina. The focal length of concave lens is negative, so a lens with negative power is required for correcting nearsightedness. The power of the lens is different for different eyes depending on the magnitude of their nearsightedness. Second, hypermetropia. It is also called farsightedness. In this defect, the eye can see distant objects clearly but cannot see nearby objects distinctly. This means that the near point of the eye is no longer at 25 cm but shifts further away. As shown in the figure, the images of nearby objects get formed behind the retina. There are two reasons for hypermetropia. Number one, curvature of the cornea and the eye lens decreases so that the converging power of the lens becomes less. Second reason, due to the flattening of the eyeball, the distance between the lens and the retina decreases. So these are the two ways, or these are the two reasons. Due to that, there will be the hypermetropia. This defect can be corrected by using convex lens with proper focal length. This lens converges the incident rays before they reach the lens. The lens then converges them to form the image on the retina. The focal length of a convex lens is positive. Thus, the spectacles used to correct farsightedness has positive power. The power of these lenses is different depending on the extent of farsightedness. Now third is presbyopia. Third defect, presbyopia. So generally, the focusing power of the eye lens decreases with age. The muscles near the lens lose their ability to change the focal length of the lens. The near point of the lens shifts farther from the eye. Because of this, old people cannot see nearby objects clearly. Sometimes people suffer from nearsightedness as well as farsightedness. In such a case, bifocal lenses are required to correct the defect. In such lenses, the upper part is concave lens and corrects nearsightedness, while the lower part is a convex lens which corrects the farsightedness. So these are the three defects that we studied today here. First one is the myopia, second one is metropia, and third one is presbyopia. Apparent size of an object. Consider two objects, PQ and P1Q1, having same size but keep at different distances from an eye as shown in the figure. As the angle alpha subtended by PQ at the eye is larger than the angle beta subtended by P1Q1. PQ appears bigger than P1Q1. The apparent size of an object depends on the angle subtended by the object at the eye.